All right, so far we've talked about matrix multiplication sort of from a theoretical sense. We did a one by hand calculation. But matrix multiplication, as we've already seen, is a little bit more finicky than matrix addition, which was already a little more finicky than what we were kind of used to dealing with regular numbers. Matrix multiplication, again, kind of plays by different rules. And even more so than matrix multiplication or matrix addition, rather, when you multiply matrices together, there are a lot more little pieces that go into it, and it's a lot easier to slip up. So, even more than what we talked about with addition in the previous section, I really do recommend that we use technology to try to avoid, possible little slips here. I know I'm still prone to do things if I'm not careful, even now, and I've been working with these things for decades at this point. So you'll notice I've already got the matrices A and B kind of popped into an Excel spreadsheet here, like we did with the previous section. We'll look at both how calculators and Excel can make our lives easier in dealing with matrix multiplication. I did not bother loading the matrix I into Excel as it appears in the Moodle file, but I do have it stashed in my graphing calculator. So if you need a refresher on how to load a matrix into the calculator, take a look at the video that we did on this stuff in the previous section on matrix addition and scalar multiplication. All right, so as it turns out, once you've got the matrices loaded, just like we saw with addition, the calculator is clever enough to know to do the matrix multiplication, appropriately just with the regular times key on the keyboard. So if I go in, and I just tried to do A times B. I know technically this one actually comes second in the list, but let's go get it. So there's A times B. You see the size is listed right there. Now, for what it's worth, from what we've talked about before, you can tell just from looking at this, trying to line up A times B doesn't work because this the inner values don't match up. We've seen that's how that needs to work. So I shouldn't be able to do this calculation, in my calculator. And lo and behold, if you try to do A times B, you get this error message. Now, for what it's worth, if you were asked this, I generally would prefer for you to say that the multiplication is not defined or undefined, rather than just doing what I'll often see happen, where a student will just tell me dim mismatch because they, that's what the calculator told them. But in this case, that is an indication that the multiplication is undefined because the size of your matrices don't line up right. Anyway, so let's get rid of that guy. He's silly. Now, working through the other operations, we can do B times A, because B is 4 by 3, then we have a 3 and a 3 matching up, so we should get another 4 by 3 matrix out of this when it's all said and done. So if we do B times matrix A, so taking care of the by hand calculation, speeding this up for us, Shazam, there we go, there's our product matrix. So again, it's 4 by 3, the size we expect. And you can check if you want to do this by hand. These values do, in fact, match up with what you would expect out of this thing. All right. Now, moving on, there is an example there that says that A times B transpose would work, because remember, the transpose of a matrix, you swap the rows and the columns, so then you have a 3 by 3. Here, let's go back and look at the matrix menu to show it. So A is a 3 by 3. If we flip-flop our rows and columns, B is then 3 by 4, so we should be able to do that on multiplication. So let's do A times, and I'm doing this as much just to show off where the transpose guy actually is in here. So we are finally actually going to use this section labeled math. We're actually not going to need most of the operations that appear in here, but this thing that looks like a T, that's our notation for the transpose of matrix, so you don't have to worry about building the transpose matrix yourself. This knows to do B transpose and then do A times that transpose. We do the calculation. We get some stuff. As we've seen before, it's a bit big because of the 3 by 4 thing, but we can scroll around with the arrow keys to get all the numerical values we need. All right, the last of these guys that I want to take a look at is this I times A that ends up appearing, on at the end here. So like I said, I did load A in advance, so you might have noticed the structure of the I matrix is a bit special. So we go down here, we get matrix I, we do the multiplication, we go back in and we get I times A, we hit enter, we get our product. You may notice that product looks a little familiar, right? If you compare this to the matrix A that I've got sitting here in Excel, Yeah, they're exactly the same. That's actually, the I matrix is something kind of special. We refer to it as an identity matrix. So as it turns out, if you can do a multiplication by the identity matrix, whether you do it on the left or the right, it turns out you will always, end up getting your other matrix back if you're able to do the calculation. So it's kind of special. In a world where I had more time to talk about it, I could start talking about other, things that end up coming out of this, but we don't really have time right now. All right, so that's calculator matrix multiplication. Let's take a look at how this would end up working out in Excel. It's a little bit trickier in Excel because of the structure of the command. So I would encourage you, if you don't already have the notes file sitting handy, go ahead and go grab it. So I've got A and B loaded here. I said before we can't actually do that multiplication. Let's do B times A. Excel is also not quite as good as a calculator in terms of telling you that you've done something wrong. So be a little careful there. Make sure your sizes line up appropriately. All right, so looking through the matrices, I've got A and B loaded. I've labeled my product. Now you'll notice the directions for Excel say I need to highlight the appropriate space. So you do need to figure out what it is in advance. So in this instance, B is 4 by 3, A is 3 by 3. Our squeeze play principle tells us that the product matrix should also be 4 by 3. So I'm going to highlight a 4 by 3 grid. That part is going to be important for what comes next. So now, while this thing is still highlighted, don't click on anything random. So you should be able to hit the equals key. You'll notice the cells stay highlighted. If they don't, stop and do it again. It will mess things up if you don't. So the command, and is mmult for matrix multiplication. Excel is kind of nice in that it gives us this handy little tooltip that tells us that suggests that might probably the command we're after. We need some parentheses, and now we need to do a drag and drop on the cells of our matrices in the appropriate order. So in this instance, I'm going to highlight B because it's on the left. Then I hit a comma. Then I highlight the cells for A. I close up my parentheses. Now be very careful here. If you're following along, you might have already hit enter. You'll only have a single number and you'll have no idea why. What you need to do when you do a matrix calculation like this, hold down the control and the shift keys while you hit enter. So it's like a 3-finger salute of sorts. Control, shift, enter. And in fact, we do end up getting that product matrix that we saw when we worked this out on the calculator earlier. So do keep that in mind. The control shift enter thing, it feels like every time I have somebody do this, there ends up being somebody who forgets and says, all I got is a 4. Well, you do need to hold down control shift enter. So in class, I almost have people do this, like in cadence, like everybody says control shift enter all at once. So try to keep that in mind. All right, so let's take a look at a couple more of these examples here that are listed in the notes file. So I have gone ahead and loaded the matrices A and B from exercise 42 as it appears in our textbook. So same thing, it asks us to do the product matrix A times B. So if you look at these guys, they don't quite fit on the screen, but you can tell they're each 5 by 5 matrices. So the product matrix will also be 5 by 5. I'll go ahead and highlight the appropriate space. That is a 5 by 5 grid equals mmult for matrix multiplication. I grab the stuff from A. It's highlighted nice and blue. I hit comma. I get the stuff for B. He's now highlighted in red. I don't need a comma like I just typed there. I need to close up my parentheses. And what do I hit? Pause for effect. Right. Control Shift Enter. And my product matrix is actually, surprisingly enough, if you get rid of the decimal points, it actually just ends up looking like an identity matrix, which again is something that in a world where I had more time, we could go down the rabbit hole of exactly what that means, that multiplying these two guys together gave me an identity matrix. But for now, we're going to move on and take a look at exercise 44 instead. So this is another sort of applied type problem. So the values here, this matrix S are the sales totals for some sort of clothing manufacturer. If I remember right, the columns represent cities where they have a store, and then you have running along, in this direction. This is like suits that they sold, shirts, pants, and ties, I think. So that's your sales matrix. This R matrix is kind of a revenue thing because it basically gives you the price of each of the matrices that were, or each of the items that they could sell. $200 for a suit, 40 for a shirt, on down the line. So you're actually asked in this problem to calculate the total revenue that the company makes. So to do that, it's not quite as direct as you might hope. We will need to work out the product matrix R times S. Again, thanks to the fact that this is a 4x3 and this is a 1x4, we should end up getting a product matrix. We have to do it that way, to get the dimensions to line up right. Our resulting matrix is going to be a 1x3. All right, so I've got my 1x3 area highlighted. I hit equals, not multh, mmult. I want R first. Do my comma, do my S. What do I hit? That's right, Control-Shift-Enter. And so that auto, it actually auto expands in this instance, which was kind of nice. So now, this is the total revenue, basically from kind of each store you could imagine. But if you want the total revenue, you just need to take these three individual guys and then add them up to get one big result. So that's matrix multiplication. So you'll see some problems running akin to this, both just to be general. Here are some matrices, work out their products, and some applied examples that pop up in the homework. So now that wraps up section 3.2. We've talked about matrix addition, matrix multiplication. You might end up wondering at this point, why in the world is this the sort of thing that matters to us? We'll see sort of a situation a bit more direct in terms of how we can use matrices to make our lives easier in our next section. So stay tuned.